Pythagoras doesn't come up often, but it's easy marks when it does, and it's worth knowing about for everyday life. Right-angled triangles. We know this is a right-angled triangle because it says so, and because it's got this square here which shows that this is a right angle, and obviously it is a triangle. Now, if the question is only about lengths, then we're looking at Pythagoras. This side, the long side, is the hypotenuse. We're going to call it AH. This is A over here, and this is B down here. And the Pythagoras theorem is A squared plus B squared equals H squared. Or, in question terms, given two lengths, find the third length. If, on the other hand, we're looking at angles, say there's an X mark down here, and we're looking at lengths, so perhaps we might want to find, well, here's an angle, let's find some lengths. That sort of thing, we're talking about sines, cos and tan, or SOHCAHTOA. So it's a completely different thing. We're not looking at that, we're just looking at lengths and the Pythagoras theorem. So here's an example. Here's a right-angled triangle. We know it's right-angled because it's got a square and it says so. Find the value of x. Well, first thing I suggest we do is think. It's Pythagoras, it's just lengths. He's involved. A squared plus b squared equals h squared. And importantly, mark h on the chart because now we know what we're doing. This is h, x. So a squared plus b squared equals h squared. We know that h is x, so it's 5 squared plus 12 squared equals x squared. 5 squared is 25, 12 squared is 124 equals 169. Let's take the square root of 169, and that's 13. I like the sound of that. We'll quickly check it, obviously. X equals 13, we'll check that. 5 squared plus 12 squared equals 169. We sort of knew that. And 13 squared equals 169. So we can give ourselves a dollop of dopamine. Very happy with that. Move on to the next question. What did we do? Seeing the question, we had a little think. It's only about lengths. So it's definitely Pythagoras. There's the Pythagoras theorem, and then we mark h on the chart. And then we do it. Very simple, bit of substitution, work out that x is 13, and of course finally check it. Great. Okay, here's a slightly different example. Again, it's a right-angled triangle. It's got a square. Work out the value of x. X is this side over here. Right, we'll have a little think. It is only lengths, no angles involved. So it is my old mate, Pythagoras. A squared plus b squared equals h squared, which is h. We mark h. It's the long one. It's always the longest down here, opposite the right angle. So let's put our equation at the top. This time we have h. We know what h is, so that's 5 squared. And we've got to decide that one of these is going to be the x that we don't know. So x squared plus 4 squared is equal to 5 squared. Put in the numbers. Right, in order to get x squared on its own, we're going to have to subtract 16 from both sides. Minus 16 gives us x squared equals 9. Square root both sides, x equals 3. Question wouldn't be complete without a check, so let's do that. 3 squared plus 4 squared equals 25. Very good. And the hypotenuse is 5. 5 squared equals 25. Give ourselves a mental tick. So again, same process. We have a think. It's only lengths, so it's Pythagoras. There's the formula. We know that. We mark h so we don't make any boo-boos. Put the equation out, put the numbers in, get x on its own, square root it to find the answer, and of course after that we check it. What goes wrong? Well, there is a classic fail that crops up according to examiners' reports, and that is to misuse Pythagoras. So here's a right-angled triangle. Let's use Pythagoras, and you know, if you've sort of got a vague idea about what Pythagoras is, you know, in the same way as a bus driver might have a vague idea of which side of the road to drive on, you might write it out like that and then go, okay, 15 and 12, 15 squared plus 12 squared equals 8, or it equals 369. I'll take the square root of that, x equals 19.2. Now you can do that, but it would be wrong, obviously, because what you've confused is what h is. The hypotenuse. You've just treated these as if they are the other two sides, and this is the hypotenuse. And that's why I say when you start to think about a question, the first thing you do is you mark h over here. It wouldn't go wrong. The second thing that goes wrong, and this is in slightly more complicated questions, is you don't recognise it's a Pythagoras question. Now, if we're looking at one simple triangle, it's a right-angled triangle, and it's shown that you've got a right angle, then it's fairly straightforward. But imagine this question. Here is an isosceles triangle with height 5 centimetres, base 24 centimetres. Find the perimeter of the triangle. Okay, so the perimeter of the triangle is this distance. We need to know this distance. Not entirely obvious, but I suspect a few of you know where it's going to go, because this is all about Pythagoras. What you need to recognise is that this is two right-angled triangles. There's one sort of here. So let's have a look at that one. Call it a special key triangle. We've got 12 centimetres along the bottom because it's half of 24. We know its height is 5, and we're looking at this length here, h. So let's dig in. It's going to be the old Pythagoras. 5 squared plus 12 squared equals h squared. H is 13, obviously. It's the old famous 5, 12, 13. You've been there before. The perimeter, of course, of this shape is this length, which is h, this length, which is h, and 24. So the perimeter is h plus 24, which equals 50. But the key to this question is spotting Pythagoras, the right-angled triangle. Right. Pythagoras is not incredibly tricky, but can go astray. I'd rate it just into tricky territory. Hopefully we've made it easy. Who knows? But anyway, why not subscribe and join us for more exciting videos before sitting your GCSE resit. Thank you and best of luck.